All right, guys. Our next chapter this week, we're going to take a look at linear regression. And probably one of the most adaptable math I teach you is this concept. People get paid thousands and thousands, hundreds of thousands of dollars in the real world to basically analyze data, make a pattern of it, and make informed decisions based off of what they see. All right, these are data analysts. And basically, this is the basic version of that. So, I mean, if you're interested in this, there's definitely a career path for you down that road. So, today we're going to talk about basically a relationship between two numerical variables. We're going to be talking about scatter plots. We're going to be talking about, does a pattern exist? And is that pattern linear or is it not linear? So, real quick, if we take a look at the first section, it says a scatter plot is an informative way to display numerical data with two variables. Now, this may be new to a lot of you, but basically, it's just a graph, and you plot the points on the graph. That's all a scatter plot is. It shows a relationship between X and Y. Sometimes there may be a relationship, strong or weak. Sometimes there may not be a relationship at all, and we'll talk about that further. Now, in example 1, basically, they give us a lot of data. They say, hey, here are a random 14 cities. Of those 14 cities, we have figured out the elevation above sea level, and then they give us 3 different things that deal with these 3 cities. They talk about the mean number of clear days per year. They talk about the mean number of partly cloudy days per year, and then the mean number of cloudy days, per year. So they're giving us data, and basically they're going to compare Y, W, and Z to X. They want to see, all right, is there a relationship here? Can we say yes? And are we able to then predict, given X, what Y is, or given X, what W is, or given X, what Z is? So if you scroll past it, we see a scatter plot. Okay. This is what a scatter plot looks like. Again, all they did was they took the elevation above sea level for each city, and they looked at the mean number of days for each city, and they plotted those points on an X and Y axis. So question 1. It says, do you see a pattern in the scatter plot, or does it look like the data points are scattered? Now, if you're looking at this, and you may see it right away, you may not. At first glance, this may seem like random points. I got low points here. Oh, I have a high point here though, but this point may seem lower. Oh, but this point's really high. So at first, it may seem like just a random mass of points. But if we look closer, these points actually seem to increase. So as we go further down the x-axis, it seems that we go further up the y-axis. So as x increases, it seems that, well, my y increases. So again, it may seem like there's no pattern at all, but at a closer look, it seems like, all right, as the elevation above sea level increases, that means the mean number of clear days increase. Now, again, with these relationships, with these linear relationships, they may seem weak and they may seem strong. So if I'm looking at this from that viewpoint, again, since it looks somewhat scattered, I would say this is a weak relationship. Now, you're probably wondering, all right, Mr. Z, if this represents a weak relationship, what would a strong relationship be? And basically the answer to that, guys, is the more linear or the more put together a graph looks, the stronger it is. So if my points were closer to a line, it'd be stronger. If my points were exactly in a line, it'd be the strongest. And again, the more widespread my points look, the weaker that is. We also call this correlation. That's the main word we use. We say if something has a weak correlation, or if we say something has a strong correlation, or there may be no correlation at all. So basically, when we say correlation, we're talking about the relationship there is. Is there a strong correlation? Does it look like a strong relationship, or is it a weak relationship? Again, in this sense, it seems like it's a weak relationship. There definitely is one there, but in our sense, it's weak right now. It says, how would you describe the relation between elevation and mean number of days for these 14 cities? That is, does the mean number of days tend to increase as elevation increases, or does the mean number of days, clear days, tend to decrease as elevation increases? Well, clearly, if we look at our graph, we're definitely increasing. All right, there's no way that we could ever say it's decreasing. So again, as elevation increases, the clear days generally increase. So as elevation increases, the number of clear days increase. And again, the importance of this, and again, it's just weather. So it's like, oh, who cares? But pretend this in a business model. You have revenue or cost or profit or whatever you have in a business. People take data and they are able to make or fit a correlation with it. They're able to make it a linear correlation or a linear relationship or a quadratic or an exponential. And they're able to make an algorithm or an equation and then predict what's going to happen down the line. That's the importance of this lesson, guys, in this chapter. This is an extremely useful skill to have in the real world. Extremely useful. Number 3, do you think that a straight line would be a good way to describe the relationship between the mean number of clear days and elevation? Why do you think this? So again, we kind of already said it in the very beginning. We said there's a weak linear, because if we look at this graph, it's kind of going in a straight line, The only other options we would have, at least in Math 1, would be an exponential, which would look like this, or look like this, which this clearly is not, and quadratic, which looks like this, or looks like this. Again, those two graphs do not fit our data here. So clearly this has to be a linear. And again, although it's not strong, a straight line would describe this relationship. A straight line does describe this relationship. All right, let's move on. So, exercise 4 through 7, thinking about linear relationships. Below we have 3 scatter plots, guys. And just looking at the 3 scatter plots, we can kind of make some informed decisions based off of them. But let's see what the question says. It says, if one of these scatter plots represents the relationship between height and weight for 8 adults, which scatter plot do you think it is and why? So again, now we're looking at these 3 and we're thinking, what is the correlation between the height of someone and the weight of someone? Well, do we think as weight increases, height increases? Do we think as height increases, weight increases? Do we think as height increases, weight decreases? Or do we think there's no correlation at all? So, based on your observation, what would you say? And I'm assuming the majority of you are saying scatter plot 1. Scatter plot 1. As height increases, so does weight. And that makes sense, because the taller you are, the more you should weigh. Someone that's 5'5" versus someone that's 6'5", you expect a 6'5" person to weigh more. All right. Now, here's one thing we can talk about is scatter plot 3. Scatter plot 3, we notice, is kind of all over the place. And this is the thing with data, guys. Depending on how much data you have, more of the same data could make for a stronger correlation. So as we look at scatter plot 3, we see, all right, it's, well, all kind of all over the place. But if we gathered more data for scatter plot 3, it could eventually show us a pattern. Right now it doesn't, but it could eventually. But again, scatter plot 1 definitely shows us the best way. Again, as height increases, weight definitely increases. If we look at number 5, if one of these scatter plots represents the relation between height and SAT math scores for 8 high school seniors, which scattered plot do you think it is and why? So again, think about what we're comparing. We're comparing the height of someone and their SAT math score. Now, clearly I'm 6'5", and my SAT math score was amazing, but I might be just an oddity. So, if we look at this, As height increases, do our SAT math scores increase? Do they decrease? Or is there no correlation whatsoever? You're probably thinking, all right, besides Mr. Z, there is no correlation. So we're going to say scatter plot 3. It doesn't make sense to have SAT math scores be dependent on someone's height. All right, unless we're talking about, I don't know, Isaac being short or something like that. I'm just saying. But again, scatter plot 3 is talking about there is no correlation. No correlation between these. And finally, number 6, if one of these scatter plots represents a relation between the weight of a car and the fuel efficiency for 8 cars, which scatter plot do you think? So think about this. If you drive a little Toyota Yaris or one of those Coopers, Mini Coopers, those things are tiny. If you know anything about them, they also get a lot of miles to the gallon. Now think of a big rig. Think of a huge double wide truck. Do you think those get a lot of miles to the gallon? So ask yourself this. As the weight of the car increases, does my fuel efficiency get better? Meaning, can I get more miles to the gallon? Or do I get less miles to the gallon? Or does it not matter at all? Again, the question is going to be, or the answer is going to be, scatter plot 2. As my weight increases, my fuel efficiency should go down. That's why it's always better to have a tinier car unless you need to, for some reason, have a big car. But again, scatter plot 2. And this is going to be called a negative correlation. Negative correlation. As X increases, Y decreases. Which of these 3 scatter plots does not appear to represent a linear relationship? Explain the reasoning behind your choice. We already answered this in number 5. We said scatter plot 3 because there is no correlation. We can't fit a line to this. If I have a line that goes like this, that doesn't really follow the pattern. If I have a line that goes like this, it doesn't really follow the pattern. So both these lines would not work. Again, here it's clear. This is clearly going up for scatter plot 1, and it's clearly going down for scatter plot 2. So again, scatter plot 3, there is no correlation, thus it doesn't represent a linear relationship. Alright, exercises 8 through 13. When a straight line provides a reasonable summary of the relation between two numerical variables, we say that the two variables are linearly related, or that there is a linear relation between the two variables. Remember, guys, if something is linear, it has a constant rate of change. So take a look at the scatter plots below and answer the questions that follow. So before we even get started, let's look at scatter plot 1, and let's kind of analyze what's going on. It seems that as my x increases, as I go further down the x-axis, what's happening to my y values? Well, I mean, if we can make any sort of guess, it seems like it's going down. Now, would you say this is a strong or weak correlation? Do the points appear to be somewhat scattered, or are they tight-knit where it's a clear negative correlation? And in my opinion, these aren't that close. Yeah, we can obviously tell it's going down, but it's a weak negative correlation. So as we look at number 8, it says, is there a relationship between the number of cell phone calls and age, or does it look like the data points are scattered? No, there is definitely one, and I'm just going to say yes, there is one. I mean, it doesn't ask us to explain, so yes, there is one. If there is a relationship between the number of cell phone calls and age, does the relationship appear to be linear? Again, our only 3 choices are linear, exponential, and quadratic. This doesn't look exponential, and it does not look quadratic. So, I'm going to say, yeah, it looks like it's linear. Again, it's a weak correlation, but it's still a correlation nonetheless. Scatter plot 2. Let's look. Now, as we look at this scatter plot, notice how this is different from the rest. It's kind of looping down. It's not really going straight down. It's kind of dropping real fast like a roller coaster and then evening out. So, is there a relationship between moisture content and frying time, or do the data points look scattered? These definitely don't look scattered. This, I would say, is a strong correlation, because the points are almost in a line. You can kind of trace the pattern. So I would say yes. there is a correlation. I would even say there's a strong correlation. I spelled correlation wrong up here. Now, 11. If there is a relationship between moisture content and frying time, does the relationship look linear? Again, it's clearly going down, but notice, if I try to draw a line down, that doesn't really follow the pattern. If anything, this is the pattern that we have. Whoops. Went off. That is not a linear relationship. This is actually an exponential relationship, and that's something we're going to talk about in second semester. But again, no, this isn't exponential. All right. 12. Scatterplot 3 shows data for the prices of bike helmets and the quality rating of the helmets based on the scale that estimates helmet quality. Cool. Is there a relationship between quality rating and price, or are the data points scattered? So, again, quick analysis. If I'm looking at this, they're kind of scattered. They're kind of scattered. There's not really one relationship. I could draw a line up. I can draw a line going down, and it's not going to really match my pattern that I'm looking for. It's not a U. It's not like an L like the exponential was. There's nothing there. There is no correlation. If there is a relationship between quality rating and price for the bike helmets, does the relationship appear to be linear? Again, there's no correlation here. There is no pattern I can assign to this at all. I mean, if I look at it, that doesn't make sense. That doesn't make sense. You can maybe make an argument for positive correlation, but even that's thin. So again, that's pretty scattered. And guys, that's actually the end of the lesson. It's a very simple lesson, but again, it's also important to understand these concepts because you need to get the basics. And again, if you actually somewhat enjoy looking at graphs and trying to make predictions from it, and trust me, we are going to get way more intense with this concept. We're going to go really, really hard into it. But if you enjoy this, trust me, data analyst, it's one of the hot new jobs of the century, they call it. And they make a lot of money. All right. It's tough. You got to do a lot for it. But again, they make a lot of money. So, what I need you guys to do is go through the rest of these questions. I will post the answers online, but go through all of these and answer the questions that are attached to the packet. If I cut some problems off, I don't think I have this right here on the packet. So just go through, answer the questions that I've included. I'll post the solutions. And again, hopefully I get to see you guys on Monday. Otherwise, enjoy your weekend. Good luck.